Hello everyone, my name is Anupoda. So today I am going to discuss about unit number 3, software architecture and planning a software project. So the contents that we are going to discuss in this video is component and connector view, components, connectors, and with an example. Now what is component and connector view? Now the two important elements of component and connector view are components as well as connectors. Now the components are the computational elements or data stores. Now the elements which stores the data. The connector will define the interaction between the components. So CNC view defines the runtime structure of the system architecture, which means it represents the components that are actively participating during the execution of the system. So it shows which are the components which are actively participating in the execution of system. So it is represented as a graph in which each node represents the component and each edge will be represent the connector. So as you can see in the diagram, so server, okay, so server is a component, so it is represented as a rectangle. Client is a component, okay, so client is represented as a oval shape. Database is represented as you can see here, and the applications. The components, as I told, are the computational elements or data stores. Now every component has a name which represents the functionality of or role of that component. Now here you can see here there are clients, servers, filters, controllers, sensors, and so on. So there are different representation for these type of components. However, there is no standard notations for different component types, and an architecture can use its own symbol. So it is not that for server we can use only rectangle, for client we can use a oval shape. So it depends on the architect what symbol he can use for representing component and character. The only necessary thing is that meaning of different symbol used for representing the component types should be clear. Okay. Now components also use the interface to communicate with the other component. So these interfaces are called as ports. So every component must clearly specify its ports. Now the components of the system can be either simple or complex. Suppose if the components are complex, then they may have their own structures. So this structure of internal architecture can be understood by decomposing the complex components of a system. Now let us see what is connectors. Now as I told, connectors are used to connect the components. So different components interact with each other to provide the services. So a group of components can be interact by providing different functionalities. So if all these components are combined together, then they will deliver the overall functionality. Now the interaction between components is provided by means of connectors. Okay, and the interaction can be simple like procedure call, or it can be a complex such as remote procedure call in a distributed environment, and use of a TCP/IP port, or communicating in client server environment using HTTP protocol. So these are the examples. So in complex mechanism, it is very important to identify all the components which are taking part in the communications. Okay, now every connector must have some name as well as type. Now the type of the connector will describe the nature of the connector and type of interface it supports. So these are the notations that are used for connectors. So the first one is the bus type connector. So it looks as if the buses are connected in the CPU. Then there is a request reply. As you can see here, in the square you can see it can be a client component, and the other can be a server component. So it is interacting with each other. And the database access, you can see there is a pipe component and remote procedure call. Now let us see what is model view. So model view is anything but a collection of code units. So the purpose of each model is to implement some functionality. So models are nothing but a small parts of program. So each program should perform some functionality. So examples are package, collection of classes, collection of functions, methods, and procedures. So depending on the interaction between the modules, the relationship between them will be decided. Now so a relationship ID is code based. Now there are various types of relationships. First one is a part of relationship. This means that A is a part of module B. Uses or depends on relationship. This means that module B depends on the functionalities of module A. types of or generalization or specialization relationship. That means that B and C are the types of module A. Next one is component and connector view. So in component and connector view, the system consists of runtime entities. Okay, so these entities are called as components. So example of components are a process, object, or collection of objects. Now components interacts with each other in order to provide the system services. So components get connected to each other using connectors. Examples of connectors are pipes and sockets. In distributed environment, the middleware acts as a connector for distributed components. Now we have an examples. Now suppose we have to design an online examination system. So system can be implemented using a 3-tier architecture. So it is a web-based system. Now every student will act as a client. Now when you're designing a web-based system for online examination, so all the students will give the exam online, so they will act as a client. Now each student has to answer multiple choice questions. So when student answers all the questions, he will submit his question paper to the server. Okay, now client has submitted question papers to the server. Now server will be the second component in this architecture. Now server will compute the marks for the submitted answer, and these marks will be saved in the database. Now database will be the third component. So thus client, server, and database are the three components of this software architecture. Now let us see what the architecture of a service system. Now communication between the client and server, as we have discussed in previous slide, it is like a request and a response. So request response connector can be used. So as you can see here, there is a request response connector. So database access connector can also be used for interaction between database and the server. Now when a server makes a request for the result using a query to the database, so then the corresponding record will be returned to the server. Okay, so we are using a double RS because it is both bidirectional. The server can request to the database, and database sends the results to the server. Then the server will then display the result in the form of web page to the client. Now instead of it, we can use the authentication for service system. Now the architecture we have shown in the previous slide has no security because a student can take the survey as many times as he wishes. So even a non-student can take the survey. Now suppose if your dean of the students wants this system to be only to the registered students, okay, and also we want only student to take only once, that is the survey has to be taken only once. So to identify the students, it was explained that each student has an account, and their account information is available from the main proxy server of the institute. Now the architecture has a separate login form for the user and a separate server component which does the validation. So for validation, it goes to the proxy server checking if login and password are provided. Now if so, the server will return a cookie saying that whether the password is correct or wrong. So based on that, he will be authenticated. So this is the service system with authentication. Now the architecture will be having a separate login form for the user, okay, and a separate server component which does the validation. So for validation, it goes to the proxy for checking the login and password. So in the previous, what was there, client was just requesting the server for checking the survey, and it was fetching from the database. But now when clients request for a survey to the server, first the server will check his login details. So the login details will checked from the authenticated server, or you can say a proxy server, for checking whether login and password are provided. Now if it's provided, it returns a cookie to the client saying that the password is correct. Now when the student completes the survey form, the cookie information will validate the user, and server checks if the student has already completed the survey. Now we use architecture for the system with cache. Now suppose we want the system to be extended in a different way, but sometimes what happens, database server is somewhat reliable and it's frequently down. Sometimes the database will be down. So when the student submits the form, the result of the survey is outdated, okay, so which is acceptable. So Dean wanted to take the system more reliable and more provide more facility for completing the survey even when database is down. So even when the database is down, the Dean wanted to make the system more reliable. So to make the system more reliable, the solution was found. What the solution is: when the student submits the survey, the server interacts with the database. Okay, now the result, as you can see in the diagram, the result of the survey is stored in the cache, okay, by the server. Now if the database is down or unavailable, the survey data is stored locally in the cache component, and the result saved in a cache component is used to provide result to the student. So there is only an extra addition of a cache manager. Okay, so whatever is stored in the cache server, what is the result, will be stored in the cache by the server. So for this, server has an other component called as cache manager. So cache manager is an another component. There is a connection between the server and cache manager of call return type. Now in this video we have discussed about what is component and connector, examples of components and connectors. Thank you.